Hi everyone, welcome back to Econ 333. In this short video, I will talk about the overview of the course, kind of giving you the logic behind the different parts of the course, and hopefully what we will learn, and hopefully what we'll be able to use after the course. So, before talking about 333, I want to talk about economics in general. One of the most basic definitions of economics would be the science that studies the allocation of finite resources. So, economic theory, macro, micro, industrial organization, development economics, labor economics, international trade, and many more, builds models, which are abstract representations of the real world, to understand what causes different phenomena. The real world is very complicated, so we simplify it, see what happens in this simplified world, and little by little, make it more and more complicated and see if we can use the conclusions of the models to understand what we observe in the real world. In particular, these models establish relationships between different measures or different variables. For instance, if you think about ECON 201, you know the relationship between the consumption of a good and the price of a good. It makes sense. If the price is high, we consume less of it in general. But what if this is the price of another good that increases? It could have no effect on our consumption, or it could have a positive effect or a negative effect. It depends on what price we are looking at. However, very often, these models do not suggest any quantitative magnitudes of these effects. They just say, well, I consume more if the price is lower, or vice versa. How much more? How much less? It would be useful to conduct policy. For instance, if the government wants to increase the tax on gasoline or on goods and services in general, the GST that we pay in Vancouver, and the PST, how much would consumption decrease? That would represent a loss in tax revenue as well as a decrease in economic activity. So that could have an impact on employment as well. And this is where econometrics comes in. Econometrics is the discipline that addresses the quantitative implications of economic models. It tries to answer questions like, does a variable x cause a variable y? And if so, in what magnitude? Couple of examples. What is the quantitative effect of reducing class size on student achievement? We know that, and it's a fact, it's been reported that lower class sizes tend to increase student performance. And now we can think about the reason why. Teachers have more time to spend on each student individually when there are 15, 20 students in the room as opposed to 40 students. This matters economically speaking because by increasing schooling performance, academic performance, this would increase productivity of these students, and that would have an impact on economic activity. Another more straightforward question: how does another year of education change a worker's earnings? You guys are about to graduate from a bachelor in economics from a Canadian university. What difference would it make if you had graduated from this bachelor from another university, a more famous university, Harvard? Or what difference does it make if you have a master's instead of a bachelor? How much more money could you expect to make once you start working? And the same for a PhD. This will have an impact on your decision. If going from a bachelor to a master's, so 1, maybe 2 extra years of school, has a little impact on your future wage, you might prefer to just stop school at the bachelor and start working right away. You will make up for this difference with experience by getting promoted. But maybe getting a master's or a PhD will make that much of a difference, and you're willing to pay tuition fees and you're willing to study extra hard to be able to get that difference on the labor market. What is the price elasticity of demand for cigarettes or gasoline or other commodities? Remember the definition of elasticity? This is the percentage change in the quantity consumed after a 1% increase in the price of a good. If the price of cigarettes increases, the price of alcohol increases, the price of a muffin, of a coffee increases, how much less will we consume? This matters for a firm. Think about a company that makes phones, like Apple or Samsung, for instance. They know they can charge $1,000 for the phone and they will find a lot of demand. But what if they change the price from $1,000 to $1,100? Maybe a lot of people will stop buying the phone, and that could represent less sales. Even if the price is smaller, the quantity could be that much. Even if the price is higher, that could represent that a way lower quantity sold, and that would reduce profits. What is the effect of a tax on the consumption of different goods? That would be a government's question. Note that these 4 different questions are asked by different bodies of society, which could potentially offer a job. The government for the tax. The price elasticity of demand would be for any private firm that sells a specific good or service. A year of education change on a worker's earnings could be different research institutes which are not necessarily publicly funded, as well as the quantitative impact of reducing class size on student achievement. In order to answer these questions, we will use data. Ideally, we would like to design an experiment to answer these questions. By designing an experiment, we can know exactly what kind of data we will need, we can get the relevant data, and we can use the most straightforward statistical tools to answer our questions. The problem is, most of the time, we only have access to observational data, survey data, online data, not experimental data. And this will come with a bunch of pickles. There could be what we call confounding effects, and I will talk about this later in the semester, simultaneous causality, or there could be the traditional problem of correlation versus causation. We could interpret something as a causation effect, this variable affects this, where in fact it's only a correlation. So in this course, we will go over these different problems and how to deal with them. The course could be broken into 4 goals overall. 4 major questions that we try to answer with econometrics. The first one is estimation. We want to make a guess, a good guess, educated guess, about an unknown value and assess how accurate that guess is. Using some statistical theory, we might be able to assess how accurate our guess is. A guess is never 100% accurate, but we could get a significant level of accuracy if we use the proper tools in the proper context. If you want to estimate an impact, you can also predict what this impact is going to do on different variables. Regression analysis will be the tool to answer that question in particular. The last 2 goals can be grouped together. They consist in hypothesis testing and confidence intervals. Both are pretty much put under the same roof called inference. We can make a hypothesis about something unknown and use some statistical theory to tell whether we are likely to believe or not believe, as in not reject and reject a certain hypothesis. For instance, we could say, is there a gender gap? That's an hypothesis. I don't know. And then I'm going to use data to estimate the real gender gap, but it will only be a guess. Hopefully a good guess. We will use some theory to back that up. And then we will try to answer the hypothesis of, is there a gender gap? Among other questions. Confidence intervals are very similar, but they are more about finding an interval such that an unknown parameter has a probability of being inside that interval. For instance, very easy example, I could say, what is the proportion of smokers in Canada? 10%? 20%? 30%? What is it? I could use a sample, look at how many smokers there are in the sample, but it will only be a sample. It will never tell me everything about the country as a whole. A confidence interval will be a way to say, there is a very high likelihood, and high likelihood is something we will talk about in detail. There is a high likelihood that the proportion of smokers in Canada is between 20 and 30%, for instance. But we could say the same thing about the gender gap. We could say the gender gap is between 15 and 25% with some probability. So, the outline of the course will be first to talk about probabilities, expectation, and distribution. This is kind of like the baseline skills I need you to understand in order to cover the rest of the course. Same as law of large numbers, central limit theorem, estimation and inference. Here I will also talk about a lot of statistical theory. With linear regression, we will start applying these concepts, and we will be able to tell how accurate our results are based on the theories seen in the first 3 weeks of the course. The main point of the course is to teach you linear regressions, is to teach you how good they can be, how bad they can be, when we can use them, when we should not use them, when we should be careful, when we don't have to be. Finally, towards the end of the course, if time permits, I would like to cover 1 or 2 topics which are related to linear regression, but these are topics that you will cover in detail in other courses. I want to introduce you to them briefly so that you have an idea of what's going on, how they work, and maybe if you like them, you might decide to take a specific course about them later on. Finally, the resources used in the course. I will use 3 books. The first one is the main one I will use for the lecture notes. Introduction to Econometrics. It is only a recommended book because I do not like to require books. Books are expensive, and if they only last for 1 semester, if they're only useful for 1 course, then you will have to spend more than $100 just for 3 months. I believe tuition fees are expensive enough so that you should not have to spend any extra money. So, this book is recommended, but if you do not use it and only look at the lecture notes, the problem sets, the lectures and tutorials, you should be fine in the course. You can still get an A+. The book is extra help if maybe there is something that I do not explain well in the course. The next 2 books, ISLR and R for Data Science, are more focused on how to implement the tools we will cover in the course in R. Since you will have to use R to complete the assignments, chances are you might have to go through these books just to get a little bit of help. Don't worry, it is not necessary, but it's very useful. These 2 books are free online. Just type them on Google. The first one is a PDF, and it's directly available on the ISLR website, and it means Introduction to Statistical Learning with R, where there will be some math, there will be some concepts that I will cover in the class, so you might get some extra resources, and I'll also show you how to use them in R. What are the commands to use in R, what are the results, what you should expect, what are the potential errors, and some exercises for you to practice if you want. R for Data Science is a book that is only targets how to use R. So it's not about how do you do regressions and so on. It's about how do you import a data set? How do you make a nice graph? How do you make a table? How do you compute the mean? How do you filter your data? How do you sort the data? How do you create new data? And so on and so forth. The book itself was written in R. And it's fully available online. Now, with this course overview, I hope that you have a big picture of the course. The big picture is always the most important thing. So keep the big picture in mind when you are going through a very hard statistical concept. Just think about it and think, okay, what are we trying to do here when you look at the big picture? Why are we trying to apply this formula here and not there? Otherwise, I will see you in lectures. Have a good rest of your week and see you in the next one. Bye.